Let's think now how we can do math with vector quantities, or with vectors or directed line segments. So here we have point P, call this point P, and it's at 1, 4, and endpoint Q over here is at 4, 5. And we connect these with a directed line segment from P to Q. And this is like a vector or an arrow, if you want to call it that. And we saw in the last video how to put this into component form. And if we were to put PQ into component form, we'd have to do PQ is equal to the open brackets to say that it's not a point, it's a vector. We would subtract the x coordinates to give this distance from here to here. So 4 minus 1. And then 5, if we were to go from this distance is 5, and this is 1. This is 4 from here to here. So I have to do 5 minus 4. And if this is unclear, just watch the last video. So PQ can be described by going 3 in the x and 1 in the positive y direction. That's PQ. Now let's say we have a different vector. Say it goes this way, and it's a little shorter than PQ. Let's make it shorter. And obviously these two vectors are not equal. They have a different magnitude, length, and they have a different direction. They point in different directions. And say it starts at point A and it ends at point B. And say A has the point 2, 3, and B is the point 4, 2. So let's put AB into component form now. So AB now would be, if I was to subtract their x coordinates, right? This is this distance from here to here is the x. That'd be 4 minus 2, comma. Now 2 minus 3. It's always the endpoint is being subtracted from. So 2 minus 3. So AB can be described as 2, minus 1, correct? We go 2 in the x direction and then 1 unit downwards. That's how, if we were to sail from island A to island B, this would be how we get there. We have to go 2 units to the right and 1 unit downwards. Now let's say we wanted to add vectors PQ and vectors AB, and that sounds a little weird because how do you add arrows? If we were to add these two segments, let me write this over here. AB and PQ. And of course, AB is just this one here, 2, minus 1. And PQ is 3, 1. And let's say I wanted to add these two vectors to give the vector AB plus PQ. To add these two vectors, I'd have to do 2 plus 3, minus 1 plus 1. And this would be, I'm running out of room. This would be the vector 5, 0. Meaning, if I was to add these two vectors, and this is just the first video. It's okay if it doesn't make that much sense to you right now. We're gonna solidify this with future videos. 5, 0. If I was to add these two vectors, I get a resulting vector of AB PQs. It's 5, 0. Now, if I was to subtract them instead, I would do the same thing, except this would be a minus sign, and this would be a minus sign. But what does this all mean? If we're just doing math on vectors, how can we represent that geometrically? And we'll see that in the next video. The main takeaway here is that when you do math on vectors, you do it component-wise. When you're adding two vectors, you add up the components. When you subtract two vectors, you subtract the components. And it has to be in component form when you do this. So let's think about this more in a geometrical sense, and we'll do that in the next video.